In this video, we are going to study final value theorem. To understand this final value theorem in better way, first go through the video of initial value theorem. So final value of signal x of t can be obtained from its Laplace domain using final value theorem. So we can say that final value theorem is used to obtain final value of signal x of t from its Laplace transform without making use of its inverse Laplace transform. That is, we need to find out the final value. So final value of x of t can be represented as x of infinity. This is the final value of x of t signal. So in time domain we can represent this as limit t tends to infinity x of t. So we are finding the final value of x of t signal and it is represented as x of infinity. Now here we are going to find out x of infinity from the Laplace transform of x of t. So here we have x of t signal whose Laplace transform is denoted as x of s. From x of s we are going to obtain x of infinity value. So we have made use of unilateral Laplace transform. So again we have to follow the same steps that we have used in the initial value theorem. So let us find out Laplace transform of, so let us consider the equation Laplace transform of d by dt of x of t equal to integration, make use of unilateral Laplace transform, so 0 to infinity d by dt of x of t into e raised to minus st dt. So we have the differentiation property of unilateral Laplace transform. D by dt of x of t is equal to s into x of s minus x of 0 minus. So let us substitute this value in the above equation. So towards left hand side we get s into x of s minus x of 0 minus is equal to, towards right hand side equation is as it is, so integration from 0 to infinity d by dt of x of t e raised to minus st dt. Now apply limit s tends to 0 on both sides. So we get limit s tends to 0 s into x of s minus x of 0 minus is equal to limit s tends to 0 integration 0 to infinity d by dt of x of t e raised to minus st dt. Now separate out the limits. So here we get the first term as limit s tends to 0 s into x of s minus the second term we do not have the s term into it, so there is no question of applying limits, so it will be simply x of 0 minus equal to limit. Now here apply the limit. So if we apply the limit, here we have only one single term of s which is e raised to minus st. So if we apply s equal to 0, so e raised to 0 becomes 1 and the term d by dt and integration cancels out and the only equation remaining in this term is x of t with the limits 0 to infinity. So let us simplify it further now. Limit s tends to 0 s into x of s minus x of 0 minus is equal to applying upper limit and lower limit, it is x of infinity minus x of 0. So here x of 0 minus and x of 0, these are initial values, so we can cancel it, and the remaining equation becomes x of infinity is equal to limit s tends to 0 s into x of s. So this equation represents the expression for final value theorem. So here we can obtain the final value of signal x of t using its Laplace transform without the need of inverse Laplace transform. So x of infinity is equal to limit s tends to 0 s into x of s. So x of s is the Laplace transform and x of infinity is the final value of signal x of t. So just to summarize, so we have the final value theorem. So final value theorem is used to obtain final value of signal x of t from its Laplace transform without using inverse Laplace. So it is represented as x of infinity. In time domain, this equation can be represented as limit t tends to infinity x of t. Then using the time differentiation property of unilateral Laplace transform, we have obtained the Laplace of d by dt of x of t. We have simplified the equations. And finally, we have obtained the equation for final value theorem, that is x of infinity equal to limit s tends to 0 s into x of s. So remember here, whenever it is final value, we have x infinity, x of infinity, that is the final value, last value. But whenever it is final value, the limit is tending to 0, s tends to 0. So here time and frequency are inversely proportional. Time is infinite, frequency is 0. Same way, if you go through the equation of initial value theorem, so towards left hand side for initial value theorem, we have x of 0. So that is time is 0. Hence the limit s is tending to infinity. Time 0, frequency is infinite. Time is infinite, frequency is 0. So remember the limits accordingly and then find out the initial and final values.